Hello friends, now let us see the questions in GATE exam from special purpose diodes. The first we will be talking about is the Zener diode. The first question from Zener diode is a Zener diode works on principle of, and that principle I have already mentioned, that is tunneling of charge carriers across the junction. Remember, in case of Zener diode, we have heavily doped P and N layers. When there are heavily doped P and N layers, there is the depletion layer width becomes very small, and there is probability of jumping of charge carriers, minority carriers across the junction. That is known as tunneling. So remember, the Zener diode works on the principle of tunneling phenomena. Fine. Now, let us see the next question. Consider the following. For Zener effect to occur, a very abrupt PN junction is required. That statement is true. In case of Zener diode, the both sides are heavily doped. For quantum tunneling to occur, a very narrow energy barrier is required. That statement is also true. So, S1, S2 is true. S1 and S2 both are true, but S2 is not region of S1. S1 and S2 both are true, and S2 is region of S1. That's your answer. Fine. A Zener diode, when used in voltage stabilization circuit, is biased in. Remember, Zener diode always works in reverse bias mode in breakdown region of the operation. I have already discussed these concepts, theoretical points in my videos. Now let us see the question. Next question. Consider the avalanche breakdown in silicon P plus N junction. P plus N means P side is heavily doped as compared to N side. The N region is uniformly doped with a donor density of Nd. Assume the breakdown of field at a point in device becomes equal to the critical electric field. Assume E critical to be the independent of donor concentration. If built-in voltage of P plus N diode junction is much smaller than the breakdown voltage, the relationship between VBR and D will be. Here basically I have to find the relationships between breakdown voltage of the diode with ND. So let us see that relation. So breakdown voltage of Zener diode is given by epsilon ER square. That expression I have already given to you. I have derived that expression. So here VB is inversely proportional to ND. So VB into ND. This is breakdown voltage. So let it be VBR. So VBR into ND is a constant quantity when critical field is constant. So these are the only questions which appeared from Zener as a device. I am not covering a Zener circuit here. Voltage regulator circuit will be discussed separately, but here we are just discussing the Zener diode as a device. So these were the questions which appeared in GATE. So just wait for my next video for more questions on special purpose diodes. Thank you.